I can solve absolute value inequalities in one variable means that we first have to discuss what a compound inequality is. And a compound inequality is an inequality that actually has two inequalities joined together, either with the word or the word and. Okay, and when we have a compound inequality, we might also see some and inequalities that are written as just a joint inequality with two inequality symbols here. This is also an and inequality. Or inequalities will always have the word or in front of them or in them. So let's go ahead and start solving this first compound inequality. To do that, we are going to divide this into actually three pieces. We have one inequality that we will solve here, and then we have another inequality that we will solve here. So we can divide this actually into three separate pieces to make our lives a little bit easier. And our goal still is to get y by itself. So that means we got to get rid of everything that's on the inside of this inequality. We will add 2 to all three parts. That's why we draw our lines to remind ourselves that we're not just doing it on one side and the other. We're doing it to different inequalities. If you'd like, you can always write these as separate inequalities. There's your first inequality and cover up to the next one. There's your second one and just solve them both out and write the word and in between them. So we have 10 plus 2 gives me 12. Copy down your symbols. 3y, copy down the symbol, and we have 21. Next, we're going to get rid of the 3 by dividing all three parts by 3, leaving us 4 is less than or equal to y, which is less than 7. The same rules apply as our other inequalities, that if we multiply or divide by a negative, we must flip the inequality symbol. But when you are finished, you should have the smallest number on the left, 2 less than symbols, and the largest number on the right. And that's a correct and inequality. To graph this, we need a number line. And we have enough numbers on here to include all of our numbers that we have here. So I'm going to start with 3, 4, 5, 6, 7, 8. So 4 and 7 are both included. And when we are graphing, we use a closed dot when it's equal to, an open dot when it's not. Closed dot equal to, open dot not. And if we have written a correct and inequality, again, smallest number on the left, largest number on the right with 2 less than symbols, then our y should be the numbers in between the 4 and 7. So that's where we'll shade. Let's do an or inequality. Number 2, we subtract 3 from both sides, leaving us with x is less than negative 1. Because they're or inequalities, I can solve them separately like this. The and inequalities are conjoined together, so we like to solve them together. Over here, I'm going to divide by negative 1, divide by negative 1. When you divide both sides by a negative, switch the sign. So I have to switch it to a greater than symbol, and it's positive 4. And don't forget the word or. That's incredibly important. If you don't have the word or, it's not considered a correct answer because it could have the word and in between it and mean something completely different. Think about what these two words mean. If I said that you are both a student at Linn-Mar High School and you are in my class, then that is significantly smaller amounts of people than if I just said you are a student at Linn-Mar High School or you're an Algebra 2A student. You could be an Algebra 2A student at another school, or you could be a student at Linn-Mar High School taking any other math class. That's a significantly larger portion. In order to be a part of the OR group, you only had to work in one of the statements. In order to be a part of the AND group, you had to work in both of the statements. So writing the word OR is incredibly important so that you are specific about what you want your solution to be. Graphing it, we set it up the same way, enough numbers to include all of the numbers in our solution. So -2, -1, 0, 1, 2, 3, 4, 5. And we use an open dot on -1, a closed dot on 4. And since these are two separate inequalities, we're going to graph them the same way that we did the ones that were all by themselves in the last standard. Check to make sure they're in Venn form, which they are. Variable first, then the inequality, then the number. And we are going to shade in the direction that it's pointing. Pointing to the left, shade to the left. This one, pointing to the right, shade to the right. Now, when you are solving an absolute value inequality, you have to follow these steps here. You have to get your absolute value brackets alone, just like in the equations. You're never going to distribute inside. You have to make sure that your absolute value brackets are on the left. And then you're actually going to decide if it's an AND or inequality. Now I have a couple of phrases to help us remember if it's an AND or inequality. And here they are. You may want to pause this to write it down. And it's less than and great or. That has to do with the symbols that are below it. So when we're done solving it out to get the absolute value on the left side, and I have a less than symbol, so less than 5, that means that I'm going to set up an AND inequality, which looks like this. The two numbers that have an absolute value of 5 are -5 and +5. What's inside of the brackets goes in the middle. And remember, our AND inequalities have two less than symbols. When we have a great or, we have our absolute value on the left, the greater than symbol, and we will set up our two inequalities like this. The two numbers that have an absolute value of 5 are the 5 that's already here and the -5. The 5 that's already here gets to keep the sign it's given. The -5 was new to the party, so he gets what's left over, which is a less than symbol. And don't forget the word or. Okay, let's look at the next page. We've got two examples to work through that are just simple ones, just like I just showed you on the other page. Remember, our first step was to get that absolute value on the left side by itself. It's like the beginning of Venn form. So we want the absolute value on the left and the 2 on the right. It's opening towards the 2 and away from the absolute value, so it needs to open towards the 2 and away from the absolute value. When it's in this position, we have a less than symbol. Okay, I know that I'm not saying less than right. I'm saying it this way on purpose to help remind you that when it's a less than symbol, it is an and inequality. So we are going to take what's inside of the absolute value and putting it down to be the middle. We are going to take the number here, and what two numbers have that absolute value? -2, it's smaller, so it goes on the left, and +2, it's larger, so it goes on the right. And two less than symbols. Okay, let's practice graphing this. So we have an open dot here and an open dot here. And I have it set up properly. Smallest, largest, two less than symbols. So the D falls in between those two numbers. That means that the shading falls in between those two numbers. Let's take a look at the next one. We're going to rewrite it so that that absolute value is on the left. So absolute value of D on the left, 3 on the right. It's opening towards the absolute value, so it needs to continue to open towards the absolute value, which means this is a great or symbol. So when I set this up, what's in between the brackets is going to go on the left side of both of the inequalities that you set up. The 3 was the original, so he gets to stay here. -3 is also part of the party, so he gets to go to the other one. And our inequality symbols, remember the original stays with the original, the opposite goes with the opposite. Okay, and we don't forget to put an or in the middle. Graphing it. Enough dots or lines to accommodate all of our numbers. We have an open dot at -3 and at +3. Here, it's pointing to the right, so we'll shade to the right. It's pointing to the left, so we'll shade to the left. Let's do 2 more examples that have a little bit more to do. These are closer to like what you're going to see on the actual quiz or on the homework. So the absolute value is already by itself. It's already on the left, so we can make a decision here about is it less than or greater than great or. This is a great or symbol. Which means I'm going to have what's in between here set up twice. 2x minus 2 and 2x minus 2. I'm going to have the number here and its opposite, and then the inequality with the original and its opposite. Now it's time to solve. Add 2 to both sides. It gets solved just like a normal set of inequalities. Divide by 2 on both sides. Over here, we'll add 2 to both sides. Divide by 2 on both sides. And x is less than or equal to -1. And we don't forget to have an or in between them in my answer. I'm going to skip graphing this one. because it's the same process as what we've done several times before, including the last standard. And take a look at number 6. I have to get this absolute value by itself. So that means we will add 7 to both sides. Negative 5 plus 7 gives me 2. It's now time to evaluate, is it a less than or great or? Since this is a less than symbol, it is a less than. Which means that I'm going to have the inside of the absolute value brackets set up just once in between. And the 2 and its opposite, negative 2, will be set up in order of the smallest on the left, largest on the right, with 2 less than symbols. And don't forget to make them equal to, because the original was equal to. When we solve this, we will subtract 2 from both sides. By both, I mean all 3. Giving us negative 4 is less than or equal to 2. X is less than or equal to 0. Divide by 2 on all 3 parts. And negative 2 is less than or equal to x is less than or equal to 0.